Welcome to our channel Autodrive. The U.S. Navy's fiscal year 2026 destroyer effort represents a deliberate shift from incremental upgrades to a generational leap in surface combatant capability. For decades, the backbone of the fleet has been the highly successful Arleigh-Burke-class destroyer, a warship that has proven itself in air defense, ballistic missile defense, and strike operations. However, evolving threats, ranging from hypersonic missiles to increasingly quiet submarines, have driven the United States Navy to pursue a more adaptable and power-rich platform. This next-generation vision is widely associated with the DDG-X program, designed not merely as a replacement but as a future-proof warship capable of integrating technologies that are still emerging. One of the most significant design priorities of the FY2026 destroyer is its integrated power system. Traditional destroyers rely on gas turbine engines primarily optimized for propulsion, with electrical generation as a secondary function. The new design flips that mindset by building in substantially greater electrical capacity from the start. This is critical because modern naval warfare is increasingly energy-centric. Advanced radars, electronic warfare systems, and especially directed energy weapons such as high-powered lasers require immense and stable electrical output. By designing the ship with expanded power margins and scalable distribution networks, the Navy ensures that future upgrades, whether railguns, improved sensors, or enhanced defensive systems, can be accommodated without overloading the ship's infrastructure. In simple terms, this destroyer is built with room to grow rather than being pushed to its limits. From an external perspective, the hull and superstructure reflect a continuation of stealth-conscious naval architecture. While not as radically shaped as experimental vessels, the ship incorporates angled surfaces, enclosed sensor masts, and minimized protrusions to reduce radar cross-section. Infrared suppression systems and quiet propulsion engineering also reduce detectability across multiple domains. Survivability is layered into the design, with reinforced bulkheads, distributed computing nodes, and redundant communication pathways. This means that even if one section of the ship sustains damage, the combat system can reroute functions and maintain operational effectiveness. In naval combat, resilience can be just as decisive as firepower. The sensor suite forms the intellectual core of the vessel. At the heart of this capability is the latest evolution of the Aegis combat system, long regarded as one of the most capable maritime combat management systems in the world. Integrated with it is the FY2026 radar, developed by Raytheon. Compared to earlier radars, the FY2026 offers significantly greater sensitivity and range, enabling detection of smaller, stealthier targets at longer distances. It can track ballistic missiles, cruise missiles, aircraft, and surface contacts simultaneously, processing vast data streams in real time. For a general audience, think of it as a highly advanced air traffic control system combined with a missile defense shield, constantly scanning the environment and prioritizing threats before they become imminent dangers. Weaponry remains versatile and mission adaptable. The destroyer is expected to field an advanced vertical launch system capable of deploying a wide array of missiles, from long-range surface-to-air interceptors to land attack cruise missiles and anti-ship weapons. This modular approach allows commanders to tailor the ship's loadout depending on mission requirements, whether defending a carrier strike group, conducting precision strikes ashore, or deterring adversary fleets. The main deck gun provides naval gunfire support for forces ashore, while close-in weapon systems serve as the last line of defense against incoming missiles or unmanned aerial threats. As directed energy weapons mature, laser systems are expected to supplement traditional munitions, offering low-cost per-shot defensive capability against drones and fast attack craft. Undersea warfare capability is another critical dimension. Submarines remain among the most lethal threats in maritime conflict, and the FY2026 destroyer integrates advanced hull-mounted sonar, towed array systems, and anti-submarine torpedoes to counter them. Helicopter facilities and unmanned aerial or surface vehicles extend detection ranges beyond the ship's organic sensors. By combining acoustic detection with aerial reconnaissance, the destroyer forms part of a layered anti-submarine defense network that protects high-value assets such as carriers and amphibious ships. Performance characteristics emphasize speed, endurance, and operational flexibility. Modern gas turbine propulsion, supported by experienced defense integrators like Lockheed Martin in combat systems integration roles, ensures reliable high-speed transit while maintaining fuel efficiency for extended deployments. Automation plays a transformative role as well. Digital monitoring systems reduce the required crew size compared to earlier generations, lowering life cycle costs and reducing sailor workload. At the same time, improved living quarters, better climate control, and advanced communications enhance crew quality of life during long deployments. Perhaps the most compelling selling point of the FY2026 destroyer is its architectural philosophy. Instead of being designed around fixed capabilities, it is built as a scalable combat platform with excess capacity in power, cooling, and space. This growth margin ensures that the vessel can integrate hypersonic missile defense systems, next-generation electronic warfare suites, or emerging artificial intelligence-driven decision aids as they mature. In an era where technological cycles are accelerating, adaptability becomes a strategic advantage. Strategically, this destroyer embodies deterrence through visible capability. It serves as a multi-mission platform capable of air defense, missile defense, anti-submarine warfare, strike operations, and command and control functions within a networked fleet. Rather than operating as an isolated warship, it functions as a node within a larger information and combat network, sharing sensor data across ships, aircraft, and joint forces. In practical terms, that connectivity multiplies the effectiveness of the entire fleet. Ultimately, the FY2026 destroyer represents a synthesis of proven experience and forward-looking innovation. It carries forward the combat reliability of legacy platforms while preparing for the technological realities of future conflict. For policymakers, it signals sustained maritime strength. For sailors, it offers a more capable and resilient platform. And for observers worldwide, it stands as a visible demonstration of how naval engineering continues to evolve in response to an increasingly contested global maritime environment.